Hello dear students, I hope you are doing well. So I'm going to start a new topic in this video. So we'll start with types of redox reactions. Number one is combination reaction. So you have already studied about combination reaction in class 10, so I'm sure you have some idea about combination reaction. It's basically when two or more species combine to give one product. That is combination reaction. So let us see how a combination reaction can be a redox reaction. So let us take the example of H2 plus O2 gives H2O. Balance it. 2, 2. Now the oxidation number of H2, that is hydrogen, is 0. Since it's molecular form and it's homoatomic, oxidation number is 0. O2, oxidation number is also 0. In H2O, the oxidation number of hydrogen is +1, whereas oxygen is -2. Now after writing the oxidation number, you can say for hydrogen it is from 0 to +1, which means it increases. And since the oxidation number increases, it is oxidation. Whereas for oxygen, the oxidation number is 0 in the reactant, but when it forms the product, it becomes -2. So from 0 to -2, there is a decrease in oxidation number, so therefore this is reduction. So you can say in this reaction, which is a combination reaction, you have both oxidation and reduction, so therefore this is a redox reaction. So this is how a combination reaction can be a redox reaction. Next type of redox reaction is decomposition reaction. So you know, decomposition reaction is a reaction where one reactant will decompose to give two or more products. So let us take an example of decomposition reaction. H2O2, which is known as hydrogen peroxide. So it will decompose to give H2O, water, plus oxygen, that is O2. You have two oxygens here, 1, and if you multiply this by half, if the stoichiometric coefficient is half, it's balanced now. 2 hydrogen, 2 hydrogen, 2 oxygen, you have 2 oxygen in reactant also. Now let us write the oxidation number. Hydrogen is +1. Oxygen, since it's peroxide, the oxidation number is -1. In product, H2O, hydrogen oxidation number is +1, oxygen is -2. Whereas for O2, the oxidation number of oxygen here is 0. Now you can see from -1 in the reactant to 0 in the product. That is from H2O2 to O2, the oxidation number of oxygen increases. So therefore, this is oxidation. Whereas from H2O2, the oxidation number of oxygen from -1 to H2O, oxidation number of oxygen is -2. There is decrease in oxidation number. So therefore, this is reduction. Now you can say this is a decomposition reaction, and in this decomposition reaction you have both oxidation and reduction. So therefore, this decomposition reaction is also a redox reaction. So this is also one type of redox reaction. Next is displacement reaction. So let us take an example of displacement reaction. So Zn plus CuSO4, that is copper sulfate, will give ZnSO4, that is zinc sulfate, plus Cu, that is copper. Now you can see in this reaction, zinc will displace copper from copper sulfate to form zinc sulfate and copper. So therefore, this is an example of displacement reaction. Now let us see how is a redox reaction. So in the reactant, zinc oxidation number is 0. In product, Cu oxidation number is 0. Oxidation number of copper, if you find using the rules for oxidation number, so let it be X plus sulfur is plus 6. Oxygen is minus 2 multiplied by 4 is equal to 0. So if you solve this, X plus 6 minus 8 equal to 0, which implies X equal to plus 2. So oxidation number of copper here is plus 2. Similarly, if we calculate for zinc, in zinc sulfate, that is X plus sulfur is plus 6 plus oxygen is minus 2 multiplied by 4 is equal to 0, which implies X plus 6 minus 8 equal to 0, X equal to plus 2. So the oxidation number of zinc here is plus 2. Now from zinc 0 to ZnSO4, that is zinc to zinc sulfate, the oxidation number of zinc increases, that is from 0 to plus 2. So therefore this is oxidation. Whereas from copper sulfate to copper, that is oxidation number of copper in copper sulfate is plus 2, to copper with oxidation number 0, the oxidation number decreases. So therefore this is reduction. And since you have both oxidation and reduction in this reaction, this is a redox reaction. So therefore, displacement reaction is also a type of redox reaction. Next type of redox reaction is disproportionation reaction. So disproportionation reaction. Now the disproportionation reaction is a reaction where the same element will undergo both oxidation and reduction. Let us try to understand with the help of an example. So H2O2, hydrogen peroxide, will give H2O plus O2. To balance it, we'll multiply it by half. So oxidation number of hydrogen here is plus 1, oxygen is minus 1. In H2O, oxidation number of hydrogen is plus 1, oxygen is minus 2. O2 oxidation number is 0. Now you can see here, oxygen from minus 1 to 0 is oxidation. Oxygen from minus 1 to minus 2 is reduction. So you can see in this reaction, the same element, that is oxygen, undergoes both oxidation as well as reduction. So therefore, this is disproportionation reaction. So again, minus 1 to 0 is oxidation. Minus 1 to minus 2 is reduction. And since you have both oxidation and reduction in this disproportionation reaction, this is also a redox reaction. So we can say disproportionation reaction can also be redox reaction. So in the next video, we'll try to understand how to balance a redox reaction.